Hello everyone, welcome to my YouTube channel. Today we will learn about AdaBoost. Okay, so we will learn about AdaBoost. Now, AdaBoost is one of the algorithm which is following basically the boosting technique. And what does the boosting technique is? The boosting technique is we are building, suppose this is our training data and we are passing the data to our model 1, and then these are all weak learner, and collectively this is probably my model 3. Collectively first we will pass the data to here, and then from here we'll pass the data to here. All the rows or error rows actually we'll pass it to here, and then we'll pass it to here, and that's the way, and then we'll find the final solution. That's basically the boosting technique. So basically we will create multiple decision tree 1, decision tree 2, decision tree 3, and then based on that multiple weak learner will be combined, then it will be a strong learner and it will give us the best result. Now, for AdaBoost, one thing you have to first keep in mind, like when we are creating these trees, these are called actually stump, STUMP, and these are just one level down. So your tree will look like this. So this is our step one. So first we have to create the first model which we are creating, that will be something like this. So this is the first stump we are creating, and here let's consider this is level 0 and this is level 1. Only the tree will grow like this, and this is done. Okay, so this is probably, let's consider our step 1. Okay, now the thing is, because when we are building any kind of tree, we have to check, okay, what will be our features. So for that, let's consider we have some data like this where we have salary, uh, and then the credit, and then based on that it is saying whether you will get approval or not. So based on the salary and your credit history, if suppose there is a loan or something, you will get whether it's approval, yes or no. Okay, so this is our data look like. Now you all kind of know that when we are working on a decision tree classification problem, what we have to do, we have to find out, like, okay, we will select, probably this is my feature 1 and feature 2. We'll try with both of these features. First we'll try with the feature 1, and then we'll try with the feature 2, and we'll see where exactly we are getting the maximum information gain. Right, so let's try. We are still on the step 1. So what we will do, we'll create basically two trees, one like this, another will be also stump because only one level down. But in the first case, what we will do, if it is less than equal to 60k, and in the second case we'll say, okay, credit equal to probably uh, good. Okay, so in this case what will happen when we'll come to this condition, so how many will go to on the left hand side? So left hand side is actually my yes, and this is no, again this is yes, this is no. So if we check our data, if you see our data, basically we have less than equal to 60k is no, less than equal to 60k yes. So when it is going to the yes condition, we'll get one yes, two yes, so two yes. and how many we are getting no, it is satisfying less than equal to, so only one no, two no's here. So we'll get two yes and two n. What about when we are greater than equal to 60, less than equal to, so now greater than. So greater than condition is this one. It is saying one no, one yes, and one yes. So that's mean 2y and 1n. Okay. Based on this condition, like if credit is good, yes or no, based on this condition, if we do the split, so what will happen? Like if you check the data, so if first is bad, so that's mean it's not good. So it will basically split like this way. So 3y and 0n, if you see the data, because good, so yes, 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 so 3 0, but there is nothing with the good equal to no. Okay, and same way we can check it, 1y, 3n. Cool. So now just by seeing this we can see that this is having more pure split, right? Here we have more pure split, and when we have a more pure split, obviously this will give me the max information gain. Okay, so that's mean out of these two features we will start with this feature, and that's the way first step will work, and the first step will build the model, this one. So it will build this will be built in the step one. Hope up to this it is clear to everyone. Okay, very simple, but hope this is clear up to this to everyone. So we are basically creating the stump, because we are all the trees will be like this, and based on this we will take a decision that okay, which one is having the max information gain, and we by that particular feature we will build the tree. Cool. Okay, now we will go to the next step. Okay, so my step 2, so this is now my step 2. Step 2 is we have to assign sample weights to each of the observation. So we will assign some sample weight to each observation. In this case, we will assign 1 by 7 because we have only 7 observations. So we will just assign 1 by 7. So that's mean what will happen. So if I just keep this table as it is, so sample weight will be 1 by 7, and all the values will be 1 by 7, because that's my initial sample weight. Okay, let me quickly write it down. 1 by 7, 1 by 7, 1 by 7, 1 by 7. Okay, cool. Now the next part, again step 2, we are still under step 2, but now basically what we have to do, we have to calculate few things. So now again we are coming back here in our note. So here now we'll talk about sum of total errors, sum of total errors, and performance of the stump. Performance of the stump. STUMP. Okay. So this is my step 2, final step kind of thing, because now the stump was there, but now we need to make sure that okay, the stump is right, but whether stump is giving me all the right answer or is there any error, and how my performance is. So that's we have to calculate. So for that, what we have to do basically, we have to now calculate now calculate the sum of total error. Okay, and how do we calculate this sum of total error? And first I will show you that thing, sum of total error. First we will calculate this thing, how we will calculate this thing. Okay, so we have identified that okay, this is the tree, this is the tree which will this is my first tree, so this is my first tree. So let's see dt1. And if I just follow this tree, what does it mean? Like if the data is coming into this node, that's mean it will be n, and if it is coming into this node, that's mean it will be y, because the majority is like this and my split is like this. So if the data is coming in this way, that's mean it's y. If the coming is in this way, that's mean it is n. So if we see our data, you will see less than equal to 60, no. Okay, sorry, we'll go by the credit. Sorry, my bad. If it is bad, that's mean it's no. Okay, fine. It's good, yes, so it's fine. It's good, yes, so it's fine. It's bad, okay, fine, no problem. Good, fine. Na, that's been not equal to, so it will be like this, and it should be no. So this particular record is actually not correct, because my actual observation is showing yes, whereas my model will tell that this is no. So that's why we will say that our total errors, so probably just let me change it here in a different color so that I can write it down properly, is 1 by 7. I hope you understand up to this. This is very, very crucial. Okay. And then we will calculate basically the performance of the stump. Performance of the stump. Okay. And what is the formula? 1 by 2 log of 1 by 1 minus total error divide by total error. And remember here the log is base e. Okay, this is just keep in mind. So if I just put all the things, you'll see I'm not doing everything because I already have this information in handy. So it will come like this, and finally it will be 0.08, sorry, 896. It will come something like this. So let me just write it down, 0.896. So very, very important two things we first understand. One is the sum of total errors, another is the performance of the stump. These two my step 2. So step 1, let me just probably circle it so that when I'll share this notebook it will be easy to follow. So this is the step 1, and in the step 2 what we did, okay, my first model is ready, but now I have to calculate my performance of the stump. Okay, so ultimately what we are doing basically, like if you just from the function point of view, so we are basically doing something like this kind of function. So let me just keep the black color so it will be easy to follow. Okay, so basically we are trying to create a function like this, where this performance of stump, which is alpha 1 of model 1, which we just built, and then similarly we'll calculate alpha 2 of model 2 and alpha n model n. Okay, and then that way we'll finally get the result. So in this case, this alpha 1 is basically 0.896 and then model 1. Okay, clear up to this? No issue? Okay, good. So what is the next step now? Now we'll go for the next step. Okay, so step 1, step 2, clear. I just marked it in a red color so that we can easily understand that this is the observation which came wrong, prediction came wrong after my first decision tree, because ultimately we are doing this thing, right? We are creating multiple stump and then we'll take the final decision. So after the first stump, what happened? Like we found, okay, I have one record wrong. I'm in my example. Remember, in real life, what will happen? You will have probably a lot of records and a lot of records will be wrong. But just for example here, so in the step 2, after step 2, we found that, okay, this is the wrong. So now we have to find a way to identify. So basically now we will go to the step 3. So let me just go down, probably I'll just go here so that it will be here. Okay, so now we are focusing on step 3, and this is again very crucial. So what is this? Now we have to update the weight for correctly and incorrectly specified. Update the weight for the correctly and incorrectly specified observations. Okay, that's the important part actually. That's my step 3. So let me do in the red color so later we can understand actually. So this is my step 3. Okay, step 3 is starting from here. Go back to the color. I know it's a little difficult, but okay, please bear with me. Okay, so how we will calculate the update weights? So for that we again have a formula. What is that formula? So the formula is, for correctly classified observations, the formula is weight, which will be 1 by 7 into e to the power minus 0.896. So whatever we calculated, this one. Okay, and for incorrectly and for incorrectly classified observations, the formula is weight into e to the power, basically the performance of the stump. I should mention this way, like performance of the stump. Okay, here also this number is nothing but performance. Let me erase this actually so that it will be easy. Yep. Okay. Okay. So basically what we are saying, that minus performance of the stump. Clear up to this or not? So what will happen here, basically 1 by 7 into e to the power minus 0.896, which will be something 0.058, and here it will be 1 by 7 into e to the power 0.896, so it will be 0.349. Just do it in a calculator, you will be able to understand. Okay, so what does it mean? So that's mean updated weight, because somehow now why we are doing, okay, let's first understand, first you understand, okay, these formulas are okay, but why we are doing this thing? Because somehow we need to now identify that, okay, this is the row which was misclassified, and this is the row which we need to send for the next tree. So this is very important. Why we are doing this step 3? This step 3 we are doing because so that we can identify this particular row, that okay, this was got misclassified and we need to send it for the next tree, and that's the reason we are doing this step 3. So step 3 first step 3 is still going on. Okay, so first thing is the updated weight, and for that we have this formula, and let's put those formulas here. So now we are writing updated weight. Okay, let's just make it a little bit bigger so that it will be make sense. So what is the value? 0.058. We just calculated, right? 0.058 for all the corrected rows. So we know all these are corrected rows, that's why we can just put the same value, 0.058, 0.058, 0.058, 0.058. I'm going very slow so that you can understand this entire process. And this one, which is my wrongly classified, for that, what was my value came here in this one? 0.349. Okay, so let's put that 0.349. Okay, I'm just following the zero pattern, right? So let's write the zero also at the very beginning, and this was also got 0.058. Now the next step is basically normalize this information, because that's the way we'll easily, because that's a process actually. Okay, so that in the next, when we'll create the random values, then it will be easy to understand, because if we keep the values between 0 and 1, our main intention is to normalization is so that we can keep these values between 0 to 1. Okay, so if we normalized normalization, so let's continue this step. So next step is, so let me go here. So next is, this is the step 4. So let me write step 4. I'll just mark it in a red so that it will be easy. Okay, so what is the step 4? So step 4, again let me go to the black color. So step 4 is normalized weight calculation. So what is this? Normalized weight calculation. Weight calculation and assign bin. Okay, Now let me explain each of these things properly. Okay. When we're saying normalize mean basically what we will do is simple. We will just divide those each number, whatever is 0.058, we'll just divide it by the total sum. Total sum is 0.0697. Okay, so let me show you what I'm doing actually. So the total sum of these values are, so total sum of these values are coming actually 0.697. And when we are doing the normalization, what I am doing basically, so let me write the normalized value. Okay, we are going good. We are doing a lot of progress actually. Now we are on the normalization. Okay, so normalized value will be 0.058 divided by 0.697. So that will be my normalized value. Okay, if you do this in the calculator, it will come as basically 0.083. 0.083. Okay, and these values will be reflected here. Okay, after normalization. Okay, for this one it will be different, right? For this one it will be different because it will be 0.349 divided by 0.697. So if you do this, you will get it actually 0.501. I'll just keep the same standard so that I'll just maintain it, 0.51, and then this one is again going back to this one. Okay, this is the normalized value. Next is basically now assigning the bin. Assign bin, or basically you can say another way, just range. That's also it's fine if you say range. Okay, so this first value range will basically be between 0 to 0.8. I'll just stick to probably just first number 0.8, sorry, 0.08 actually, so I'll just go for two decimals. Okay, and then we will continue for the next values. Okay, so then the next one will be 0.08 to 0.16. Just move this one probably here so that, give me 1 second actually, let me, okay, I just put all these numbers quickly instead of holding everyone, but this is the way the bin will get created. Let me do one more thing, so make this actually into the red color because this is the error row. Okay, so I think up to this everything is clear. By chance if it is not clear, don't hesitate to reach out to me. I'll try my best to explain with other examples, or just if you need a phone call or anything, no problem. Step 1, step 2, step 3, step 4 is done. Now we are actually on the step 5, and this one, what it will do, okay, before even you go to the step 5, what will happen now, check this range is bigger, right? So that's mean when in the bigger range, you will have the bigger error records actually, right? So there is a possibility that a lot of these error records will go to the next model along with some of the good examples also, which is predicted correct. But the maximum records which is not predicted correct will definitely go to the next model. And how that will happen? Because of this step 5. Okay, sorry. So step 5, what it will do, basically, let me write slowly so that everybody can understand. Now model will run a loop and assign random value to each observation. Each observation between random values, actually here I should write it, that it should be the random value between 0 to 1 to each observations. Okay, clear up to this? And model will select maximum data from largest bin. Okay, so what will happen? So incorrect data will get picked and go to the next model. Now from the step 5, it will keep on just going the same activities. So once you are done with the step 5, then basically again you have to go back and start from the step 5, because now you have to again build your second model, because now you know what are the records you are passing to the second model, and again in the second model do the same kind of activities. So that's the way. Okay, now I will just demo how this step 5 works. So this is just, let me put in the red color so that at least we'll know that okay, these are the steps we are following. Okay, so after step 5, we'll basically run a loop and we'll identify maximum number of records from this, and we'll put it into the next model, and that's the way it will keep on going, like this way. Okay, so let me now show you the step 5, kind of a little bit of run demo kind of thing.